Hello and welcome to the online classes of science from RPS group of schools. Children, today we shall be starting a new chapter from physics, that is electric current and its effects. Children, in this chapter we will study about the following topics which you can see on the screen. Okay, let's begin with electric circuit. Children, the closed conducting path in which the electric current flows is an electric circuit. Children, an electric circuit constitutes of a source of electric current, that is a cell, a conducting wire, an electrical appliance which is bulb here, a switch or key. Now, when the switch is closed, the circuit is said to be a closed circuit. In this condition, the current flows and the appliance works, which means the bulb glows. However, the circuit is said to be an open circuit when the switch is open and there is no flow of current. Now, let's study about the sources of electric current. Children, a device that produces an electric current is called a source of electric current. For example, cells, batteries, etc. Now, battery. Children, when two or more cells are used to draw an electric current, the combination of cells is called a battery. Children, in a battery, the positive terminal of one cell is connected to the negative terminal of the other cell. Many devices such as torches, transistors, toys, TV remote controls use batteries. Children, now what is bulb? Bulb produces light and is represented by a coiled wire inside the circle as shown in animation. Connecting wires. Children, the connecting wire is represented by a straight line. It is usually made of copper and provided with insulation. Plug key. Children, a plug key is an electric switch. It is shown in the both on and off positions in the figure. A thin long line represents the positive terminal and a thick short line represents the negative terminal of the cell as shown in this animation. Now, battery. A combination of two or more cells is called a battery. Its symbol is also a combination of cells symbol as shown in the animation. Now, fuse. Children, it is a safety device in electric circuits. The components such as cells, bulbs, wires, etc. are called elements of an electric circuit. The various components of the circuit are represented by standard circuit symbols. It is much easier to draw a circuit diagrams using symbols. Therefore, we generally represent an electric circuit by its circuit diagram as shown in the figures. Now, my dear kids, symbols of some common components are shown. Now, let's just study about heating effect of electric current. When a bulb glows continuously for a long time, it becomes very hot as some part of the electrical energy is converted into heat energy. Children, this is known as heating effect of electric current. The heating element in many electrical appliances like electric rod, electric oven, electric toaster, etc. is made of nichrome alloy. Now, do an activity. Take a 10 cm long piece of nichrome wire, Tie it between the nails. Now touch the wire and switch on the current in the circuit by moving the switch on. Touch the wire again, children. Do not hold the wire for a long time and switch off the current. Touch the wire again after a few minutes. We observe that the wire becomes hot when an electric current passes through it. Children, this is heating effect of electric current. Now children, there are many safety devices which works on the same effect of current. First is MCB, miniature circuit breaker. MCB can also be used to protect the circuit from strong currents. Strong currents often leads to overheating of wires which can result in the breakout of fire. Children, fuse. A fuse is also used for the protection of the circuit which consists of a thin wire of low melting points. These days, fuses are being used rather than miniature circuit breakers. Now let us study about another effect of current, that is magnetic effect of current. Children, in 1820, a Danish physicist Hans Christian Ørsted discovered that flowing current in a conductor generates a magnetic field. Ørsted demonstrated this by connecting the two ends of a wire to a cell through a switch. Then he placed the magnetic compass near the wire. Now, when he allowed the current to pass through the wire by closing the switch, he observed deflection in magnetic needle. He also noticed that it acquires its original position when the flow of current is stopped. Okay, for this, do an activity. Take a discarded matchbox and wind an electric wire a few times around the cardboard. Place a small compass needle inside it and connect the free ends of the wire to an electric cell through a switch. After that, note the direction near the compass needle. Children, after that, bring the bar magnet near the compass. We observe that the needle gets deflected. At the same time, move the switch to the on position. We will observe that the needle gets deflected again. Now, move the switch back to the off position. We will observe that the needle comes back to its original position. So, we conclude that when an electric current passes through a wire, it behaves like a magnet. That's all about today's video, children. Thank you so much.